Picture this. You're standing before Stonehenge at sunrise, those massive trilithons casting shadows across the ancient landscape. Each stone weighs up to 50 tons, precisely positioned without a single crane or concrete foundation.
Work together.
Now imagine the moment when the last capstone was placed, thousands of years before the wheel was even invented in Britain. But here's what will blow your mind. The people who built this weren't struggling cavemen barely surviving in a hostile world. They were master engineers who had solved construction problems that would challenge us today, using principles we're only now beginning to fully appreciate. Gaze upon these ancient wonders. Structures like Stonehenge, built millennia ago. No blueprints, no power tools, no concrete. Just raw ingenuity. How did our Stone Age ancestors achieve such monumental feats? We often picture the Stone Age as primitive, focused solely on survival. Yet, their building methods were incredibly advanced, often surpassing later techniques. They weren't just surviving, they were engineering. But what if I told you that the very principles of modern engineering, from structural integrity to material science, were first mastered by people without metal? Their solutions are a silent testament to human genius. The core challenge: transforming raw natural materials into durable shelters. Think about it. No nails, no screws, no metal brackets. Every joint, every measurement, every structural decision was manual. Yet, archaeological evidence clearly shows Stone Age peoples routinely created structures that stood for decades, even centuries. From megalithic houses to sophisticated timber frames, their techniques endured. Our journey begins with the most fundamental problem. How do you cut and shape building materials when your most advanced tool is another rock? The answer reveals a truly underappreciated innovation. This innovation, controlled fracture technology. It's not simply breaking things, it's a profound understanding of how different materials behave under stress. A geological intuition. At sites like Boxgrove in England, dating back 500,000 years, archaeologists have unearthed compelling evidence. Sophisticated stoneworking techniques produced construction materials with remarkable precision. Early builders learned to read the grain structure of rocks like expert geologists. They identified natural fracture planes, using controlled pressure to split stones along predictable lines with intent. Consider Skara Brae in Scotland. From 3200 BCE, Neolithic builders split massive sandstone slabs so precisely that the joints between stones are nearly invisible. A perfect fit, without mortar. The tools for this precision stonework were deceptively simple but demanded immense skill. Stone hammers, weighing 10 to 15 pounds, delivered controlled impacts to initiate fractures. Wooden wedges were also crucial. Driven into natural cracks, then soaked with water, the expanding wood could exert enough force to split even massive stones. A clever application of physics. Bronze Age builders further refined this. They discovered that heating stones with fire and then rapidly cooling them with water could create controlled fractures that followed predictable patterns. Thermal stress as a tool. But splitting was just the beginning. Shaping these rough blocks into functional components required techniques bordering on artistic mastery. Every curve, every angle, deliberately crafted. Archaeological experiments reveal skilled Stone Age masons created perfectly fitted joints using only stone tools and an intuitive understanding of geometry. No lasers, just insight. The secret? A process called pecking and grinding. systematically removing tiny chips of stone, layer by painstaking layer, until the desired shape and smooth finish emerged. Hours of dedication. At Newgrange in Ireland, also from 3200 BCE, researchers found construction techniques that belong in a modern engineering manual. Massive stones shaped to precise curves and angles. The joints in Newgrange are so tight that no mortar was needed, demonstrating incredible precision. Analysis shows individual stones often required hundreds of hours of careful shaping by hand. This wasn't just building, it was creating architecture of enduring beauty and function, a testament to patience, skill, and deep connection to their materials, the silent artistry of our past. Now, let's shift our focus to wood construction. Without metal saws, how did they cut timber to precise lengths? Another ingenuity-driven solution emerged: controlled burning. At sites like Kalambo Falls in Zambia, dating back 300 Zuzuzunzeren years, archaeologists found wooden tools shaped entirely through controlled burning and scraping. Fire as a sculptor. The process began with careful selection, identifying appropriate trees based on species, size, and grain structure. They knew their forests intimately, understanding each wood's properties. Softwoods could be shaped faster but were less durable. Hardwoods took longer but yielded superior, long-lasting construction materials. This knowledge informed every decision. Once a tree was felled, usually by a combination of fire weakening and stone chopping, the true engineering began. Shaping timber required understanding wood's internal structure at almost a cellular level. Early builders learned wood could be split along its grain with remarkable precision, using wooden wedges and stone hammers. This allowed them to create planks and beams without sawing. They also discovered that heating wood made it more pliable, easier to bend into desired shapes. Think of the flexibility this offered for complex structures, without modern bending tools. Waterlogged sites in Northern Europe have preserved wooden building components, showing sophisticated joining techniques. These weren't crude connections, they were marvels of engineering ingenuity. Without nails or metal fasteners, every joint relied on mechanical connections, the careful shaping of wood itself. The challenge was making pieces interlock securely and permanently. The most common technique was the mortise-tenon joint. A projecting piece, the tenon fits snugly into a corresponding hole, the mortise. Creating these with stone tools demanded extraordinary precision. Archaeological evidence from sites like the Somerset Levels in England shows Neolithic builders mastered dozens of different joint types. Their joinery was a complex language of wood. Lap joints connected horizontal beams, distributing weight efficiently. Dovetail joints created permanent, strong connections that grew stronger under stress. A genius design for durability. Scarfing joints allowed builders to create incredibly long beams from shorter pieces, extending their reach and structural capabilities. Each joint type solved a specific problem with elegance. The tools for precision woodworking were specialized instruments, often taking years to master. Stone adzes, shaped like small axes but perpendicular, removed precise amounts of wood. Flint knives, with carefully shaped edges, could pare wood to exact dimensions. Bone awls punched precise holes for wooden pins and wedges, securing joints without a single metal fastener. But the most remarkable tool was the human eye and hand, working in perfect synchronicity. Experiments show experienced woodworkers can achieve millimeter tolerances with just hand tools. Stone Age builders achieved this same level of precision through years of practice and dedicated apprenticeship systems. Knowledge was passed down, refined across generations, ensuring mastery. Next, foundations. How do you create level, stable foundations without surveying equipment or concrete? Modern engineers still grapple with similar issues in challenging terrain. The answer was a combination of careful site selection and ingenious leveling techniques. They understood that a structure is only as strong as its base, a timeless principle. At sites like Çatalhöyük in Turkey, dating 7500 BCE, archaeologists found foundation systems designed to distribute building loads across unstable soils. A deep understanding of soil mechanics. Through direct observation and experience, Stone Age builders learned to identify stable soil types, understand drainage patterns, and predict how materials would behave under load. They developed techniques for improving poor soils through drainage, compaction, and the addition of stabilizing materials like gravel and sand. Early civil engineering in action. Leveling foundations without modern instruments required truly ingenious solutions. One common technique involved using water-filled trenches to establish level reference lines. Builders would dig shallow channels around the construction site and fill them with water. Since water always seeks its own level, these provided accurate horizontal references. Simple, yet brilliant. Another sophisticated technique involved weighted strings to establish plumb lines and level references. They understood basic geometric principles, creating accurate right angles with simple tools. At Stonehenge, the precision of stone placement suggests surveying techniques that rival modern methods. The foresight and planning involved are truly staggering. A celestial alignment. Wall construction presented its own unique challenges, demanding an understanding of structural forces and material properties. Load-bearing walls had to support their own weight and the roof. Without steel reinforcement or modern concrete, every wall was essentially a gravity structure. Its stability depended entirely on careful design and meticulous construction, stone by stone. Stone walls required understanding how different stones would interact under load. Builders selected stones for their structural properties, placing harder ones at stress points. The technique of dry stone construction, building without mortar, required extraordinary skill. Each stone was individually fitted, its weight and shape contributing to the overall integrity. Master builders could look at a pile of random stones and visualize exactly how they would fit together into a stable wall. This three-dimensional puzzle solving demands incredible spatial intelligence. Timber frame construction required different but equally sophisticated skills. Wooden posts and beams had to be sized and positioned to handle structural loads without failure. Stone Age builders developed empirical rules for beam sizing based on span and load requirements. They understood that deeper beams were stronger than wider ones, maximizing material use. They also recognized that wood grain orientation significantly affected strength properties. Placing wood strategically, they optimized resistance to bending and compression, an intuitive science. The most impressive Stone Age structures often combined multiple building techniques into integrated systems, a symphony of stone, wood, and earth working in harmony. At Poverty Point in Louisiana, dating to 1700 BCE, massive earthworks required moving millions of cubic yards of soil. All this without wheeled vehicles or large domesticated animals. The sheer engineering effort for these projects rivaled anything accomplished in the ancient world. a colossal undertaking built by human hands and coordinated ingenuity. Roof construction was perhaps the most challenging aspect. Roofs had to shed water, support their own weight, and resist wind forces, all using natural materials and hand tools. The solutions developed by our ancestors were remarkably sophisticated and varied by region and available materials. Adaptability was their superpower in a changing world. In areas with abundant timber, builders developed truss systems. These distributed roof loads across multiple support points, using the same geometric principles as modern roof structures. These early trusses created strong, lightweight, triangular frameworks. The joints required extraordinary precision to ensure loads were properly distributed, a precursor to modern architecture. Where timber was scarce, builders developed alternative roofing systems. Stone slabs, bundled reeds, or earth. Necessity truly was the mother of their invention. The famous turf roofs of Iceland and Scandinavia trace their origins to Stone Age techniques. Waterproof and insulating roof systems were created using local, readily available materials. Waterproofing presented constant challenges for Stone Age builders. Without modern materials like tar or rubber, they had to develop weatherproofing techniques using natural resources. Archaeological evidence shows builders used tree resins, animal fats, and specially prepared plant fibers to create water-resistant barriers, layering nature's protection. The most sophisticated waterproofing systems involved multiple layers of different materials, each serving a specific function. A multi-layered defense against the elements. Outer layers shed the bulk of precipitation. Middle layers provided backup protection and insulation, while inner layers managed any moisture that penetrated the outer defenses. Intelligent design. Quality control in Stone Age construction relied not on written codes, but on community oversight and master craftsman systems. A living, breathing quality assurance. Master builders trained apprentices through years of hands-on experience, ensuring construction knowledge was preserved and refined across generations, a legacy of skill passed down. Major construction projects were true community efforts, involving dozens of people with specialized skills. Toolmakers, stone specialists, woodworkers, and thatch experts all collaborated. The durability of Stone Age construction is attested by the many prehistoric structures surviving today. Stonehenge, Newgrange, Skara Brae, thousands still stand after millennia. This longevity reflects not just good materials, but a profound understanding of structural engineering and construction techniques. They built to last, a lesson for today. Modern engineers often marvel at their sophistication. The precision of fit, the understanding of structural forces, and the integration of multiple building systems, truly astounding. In many cases, Stone Age techniques prove superior to modern methods in terms of durability and environmental appropriateness. Sustainable building before sustainable was a word. Perhaps most remarkably, all this was accomplished using what we consider the most basic tools. No power equipment, no manufactured fasteners. Every element shaped by hand, by ingenuity. The knowledge required was encyclopedic. Master builders understood geology, forestry, engineering, material science, and project management. They were architects, engineers, and craftsmen combined. Their techniques continued to influence construction for thousands of years. Many traditional methods, used until the Industrial Revolution, traced origins directly to Stone Age innovations. Today, As modern builders grapple with sustainability and environmental impact, there's renewed interest in these ancient techniques. Natural building movements draw inspiration from them. The story of Stone Age engineering is a testament to human problem-solving. Faced with fundamental challenges, they developed solutions that were not only effective but often superior to modern ones. They proved that the most sophisticated tool of all is the human mind, applied with perseverance and creativity. A mind unburdened by limits, eager to innovate. When we gaze at Stonehenge, we're not just seeing an ancient building. We're witnessing engineering knowledge, construction skills, and organizational abilities that rival anything we accomplish today. No tools, no excuses, just genius